value store developed by Amazon for their internal use. Many Amazon services such as shopping cart, bestseller list, sale rank, product catalog, etc., need only primary key access to data. A multi table relational database system would be an overkill for such services and would also limit the scalability and availability. Dynamo provides a flexible design to let applications choose their desired level of availability and consistency. Background Dynamo, not to be confused with DynamoDB, which was inspired by Dynamo's design, is a distributed key value storage system that provides an always on or highly available experience at a massive scale. In CAP theorem, um, terms Dynamo falls within the category of AP systems, that is, available and partition tolerant, and is designed for high availability and partition tolerance at the expense of strong consistency. The primary motivation for designing Dynamo as a highly available system was the observation that the availability of a system directly correlates to the number of customers served. Therefore, the main goal is that the system, even when it is imperfect, should be available to the customers as it brings more customer satisfaction. On other hand, inconsistencies can be resolved in the background and most of the time they will not be noticeable by the customer. Derived from this core principle, Dynamo is aggressively optimized for availability. The Dynamo design was highly influential as it inspired many NoSQL databases like Cassandra and Voldemort, not to mention Amazon's own DynamoDB. Anything we want to discuss here?
I think keep reading. I think if I mean anybody, unless anybody has anything.
So I think this just to highlight, like in terms of high, like aggressively high availability, I think DynamoDB is used. So just I think we should keep an eye on like how they are creating the aggressively high availability, because like whenever high availability comes in, we often tend to get confused with Cassandra versus Dynamo architecture. So just wanted to bring some attention to that, like how Cassandra does it and how Dynamo does it is the key to understand.
I think for a system like Amazon, we need a both NoSQL databases like Cassandra as well as this DynamoDB, right? That's why I think like, if you design Amazon, right, you need a this particular NoSQL. I mean this DynamoDB for read operations, for product. For example, they can store product information, user level, card information, and all such things. As well as they can use the Cassandra for write operations, for archiving the orders and running the reporting on top of that. So that's how I would think.
These both are write heavy, right? Even Dynamo is also a write heavy machine, not a read heavy.
Dynamo is meant for read heavy operations, whereas
Yeah,
Cassandra is for write heavy, I guess. Yeah, that's how it is.
Cassandra is more like right heavy. Yeah, I second that. Um, yeah. So
Is the Dynamo is using B plus trees underneath?
What is that, Srinivas?
Is the Dynamo is using B plus tree? I mean, right, not write heavy and write fast. I mean, I meant okay. Fast writes, right? Both Cassandra as well as the Dynamo is good for writes because they are using LSM trees underneath, right?
yeah,
That means like in memory store. In memory, immediately they store the data in memory rather than disk like a SQL, right?
I mean, are we sure that this DynamoDB is using LSM trees?
That is what I was because it's a NoSQL, right? Only I mean, as of my knowledge, Only MongoDB and the SQL are using B plus right now.
I think, I think here they have mentioned Merkle trees, right? So Merkle
Merkle trees
trees.
is for synchronization actually
Okay.
across regions.
Okay.
Merkle trees is for synchronization across regions, right?
Yeah, correct. So in terms of in context of Cassandra, basically whenever we merge the SS table to optimize the merging of SS table, they basically use the Merkle tree. But on
No, no, I
contrary,
mean, Cassandra also they use Merkle trees. I think
yeah,
synchronization between regions. I think the Merkle trees concept. I
correct,
mean, I
correct. Yeah.
Yeah, I think just looked up for that and looks like it is using LSM tree, DynamoDB.
yeah,
Okay.
So it is right optimized for sure.
correct. That's what
So,
I'm saying.
so
Yeah,
does that mean like Cassandra and MySQL are alternative to each other?
Cassandra and MySQL is alternate. Usually we compare Cassandra
No,
versus MongoDB
Mongo. Yeah.
because Cassandra is eventual consistency, MongoDB is a strong consistency.
no, no, not MongoDB, DynamoDB. DynamoDB versus
The
Cassandra.
DynamoDB versus Cassandra, we can, but Cassandra is like little more expensive and it's complicated because you need a sorting key as well as the cluster key. I mean, because it's a wide area, wide column, right? That is, and
So
Another thing is like Cassandra is not read optimized, correct?
correct.
Yeah.
Even this is Dynamo is also not read optimized.
so I think
Dynamo.
I
Yeah,
think
sorry, go ahead.
I would want to add a bit of it. I think given the Cassandra and DynamoDB both actually offer configurable consistency levels, right? So in Cassandra, Cassandra can be made read optimized. Let's say if we drop the strong consistency requirement, like if it could be basically it could be kept more liberal in a way, like the current requirements and all sorts of even the one like consistency level one could be allowed, and like that makes actually Cassandra scalable for read operation as well. So I would say like both uh, also provide configurable consistency levels, and that actually makes them like sort of like flexible in terms of read versus write heavy workloads. So I would I think that this is, I think so far I have found out like this is something specific to Cassandra. Like I'm not much deep into Dynamo yet, but with Cassandra, at least Cassandra can be optimized for read for sure. With having one consistency level and like on all sorts of like basically quorum loosening the
But
quorum.
Sagar, I'm thinking that MongoDB, no, sorry, DynamoDB has this key value here, whereas Cassandra has got a wide column, right?
Yeah.
So if you read from DynamoDB,
Uh-huh.
since it's a key value,
Uh-huh.
value is like a whole object, right? So isn't that going to be faster in that case? Yeah, I understand your point that we can have a loose consistency, uh, but irrespective of that, isn't that DynamoDB would be faster
For writes or reads.
for reads?
So see the Dynamo, right? It's a consistent hashing model, and whereas Cassandra, I think later follower, right? Or even
No,
consistent.
no, Cassandra is also leader.
Consistent hashing, right?
Yeah,
Simple, no? Because we usually read from multiple partitions at the same time, right?
in Cassandra.
I mean, here also, right? I mean, we don't, I mean, like, we have three replicas, right?
Yeah.
That means if you are offering strong consistency, means when read comes, it reads from the other two replicas also in a parallel, right? It
Yes.
doesn't go for all this, it doesn't go for same node all the time, right? Or
Yeah,
it uses the replicas for faster reads, right? We can do that, right?
Correct. So the only thing that differs whether the read performance will be faster or slower is the level of consistency that we set. So let's say if it's at a quorum level, that means let's say in a quorum, let's say quorum will be like r plus w greater than n, something like that, greater than the replication factor, right? So in that case, it will wait for all replicas to respond. But if we don't choose to set it to that, it will be okay to just give away the response with even just one replica responding. That's the
No,
consistency
no,
level.
right? Because if it is a strong consistency, why do I even need to bother about that?
So yeah, in strong consistency, that's correct. But what I mean to say is it's configurable. It's not always strong consistent. It's like, let's say if we keep a simple replication strategy, and if we set the quorum requirement to just one, and if we just set the with this configuration, it will just read from one replica. It won't always it won't always wait for the other replicas to respond. In the background, it will check, it will do the checksum, and then it will also trigger the anti-entropy process or the read repair. But to just respond back to a read request, it can be set to much optimistic. I think that is, they call it
Yes.
optimistic
So,
mode.
in my understanding, how do we calculate? Maybe I'm not deviating just for a half second. In my understanding, the worst case of the read latency here, right?
Mhm.
In case of LSM trees, right? You have a mem table, and you have what is that? The cache, and we have access table. If the information is not, if the data is not there in mem table, it has to go all the way to access table and read it back, right? So that is where we calculate the read latency, whether we have multiple replicas and all. That doesn't matter. That's what I'm saying here. The overall, the lead latency is higher because in worst case it has to go and read it from SS table, right, underneath the disk, right?
So that is about reading from one particular replica, right? So I think what you're describing, Srini, is the all consistency level mode in Cassandra. Are you able to see my screen?
Yeah.
So if you see, like, the all consistency mode tells us that it will read it basically it will be, so this is, I think, read write quorum. Let me go to the read quorum, read consistency level. So in read consistency level, it will basically set, it could be set to all or quorum. If it's all, then it will try to ensure and verify it from all the replicas. If it is set to quorum, it will be fewer. And if it's set to something like any specific number like any, then it won't at all like verify with other replicas. It will just respond to the first hit that it does.
Okay.
I is So basically, this is what we covered as part of Cassandra. Like when we were reading Cassandra, I think this is where we discussed most of the things. Like they were hinting towards, like, as in, like, it depends on what the consistency level is being set. Depends on that, it will go about whether it will go about. Yeah, so I think this is to achieve strong consistency in Cassandra. It gives us R plus W. That basically, this is the each quorum level, and with and then this could be loosened up to only few replicas could respond. So if it's a simple replication strategy, then it doesn't wait for all the replicas to respond. Only if it is network topology, then it waits for all the responses from all the replicas.
Okay. Yeah. But actually, I'm still, I think this Cassandra is built on top of DynamoDB. Maybe is my understanding is correct then, right?
Possibly, but yeah, my question is,
They are very different.
Yeah, they are
Cassandra
very
and
different, right?
Cassandra uses this ring, right? Token ring, right? And DynamoDB, I thought was just a million MySQLs,
so
but I could be wrong. So why don't I just listen instead of saying wrong things? Yeah, sorry.
Maybe we'll see whether okay. But other than like more features in the Cassandra, but I feel like some of these are very pretty similar, right? This, I mean, consistency level and all.
correct.
Okay.
The underlying data structure, the way that they store data is different, though, right? It's a wide column
Correct.
storage for
Correct,
Cassandra.
correct. That is different. That's what I'm saying. But
Mm.
in the, yeah, but uh, that is the complexity of the Cassandra. Yeah.
Yeah, and I think Dynamo specifically goes for the structured table, right? Like I think we do have uh, relations here in between. Like there is a primary key, secondary key, right?
One success. The Dynamo is highly influential as inspired by many NoSQL databases like Cassandra. Yeah.
Yeah. Okay. So basically, other way around.
Yeah, other way around. Okay.
Okay. Anyways, let's. So maybe let's. Once we wrap this up, I think we should make sure. So we should make sure to collect all these topics. I would say, like, if we should note down this doubt about what are the parallels between Cassandra and this thing, we should make sure to discuss this when we complete any chapter, or when we complete any particular um, design problem, I would say. Because then the whole idea is to be able to entertain the trade-offs in the interviews, right? Like, if let's say we are grilled into, like, why some system won't be able to build using Dynamo instead of Cassandra, so we should have a concrete answer. So I think let's make sure we do that this time. Okay, shall we go ahead?
Yeah, yeah, Sagar.
Do you want to continue, or if someone else want to do?
Yasin, do you want to read?
Yeah,
As
I'll read
stated
it.
above, the main goal of DynamoDB is to be highly available. Here is a summary of other design goals. Scalable. The system should be highly scalable. We should be able to throw an machine into a system to see proportional improvement. Decentralized. To avoid single point of failure and performance bottlenecks, there should not be any central leader process. Eventual consistent. Data can be optimistically replicated to become eventually consistent. This means that instead of incurring write time cost to ensure data correctness throughout the system, that is strong consistency. Inconsistencies can be resolved at some other time during the reads. Eventual consistency
My,
is used.
my laptop battery died. I'm joining in 2 minutes.
Consistency is used to achieve the high availability. Okay. What is this diagram? Can we just go to distributed and decentralized key value store? This is high level view of a distributed key value store. Okay. So there are multiple servers talking to each other. Client can be talking to any server, and key data is like key value wherein key and value is provided. Okay, probably that whole key value pair is being replicated across the different servers. That makes it decentralized and distributed as well.
Yeah. So one
It's pretty-
one
hmm.
key difference I could clearly see here is in Cassandra we have a coordinator, and coordinator actually coordinates between multiple copies, right? Where here I couldn't see any coordinator or as such, uh, apparently. Like,
Can you Sagar, scroll up a little bit?
yeah,
I just wanted to touch upon those points here. We should scalable. The system should be highly scalable. We should be able to throw in a machine into a system to see proportional improvement. Okay, and eventually consistent is data can be optimistically replicated to become eventually. Okay, makes sense. Makes sense. And inconsistencies can be resolved at some other time. I see. I see. During the reads, which is pretty good, as good as Cassandra, right?
yeah.
Yeah. Correct. Okay. Very good. Next. Yeah, Sim. Go ahead. You want to read, right? Yeah.
Yeah, I mean, there is no difference at all architecture-wise. Okay, it's using consistent hashing model. These are also using consistent hashing model. Dynamo is pretty simpler design. Cassandra is different, but I don't think so. Cassandra also doesn't have any coordinator because this is not a leader follower rule, right?
Yeah. This is leaderless. Yeah.
Yeah, because in Cassandra also later as they where will be the coordinator comes into picture.
So whenever any query comes in, whichever server it hits first, that becomes a coordinator, right? So coordinator expects the response from the respective replica, which or respective copies, right? So here I couldn't see the coordinator function. Like, so let me, so if you see the Cassandra ring, like this is Cassandra ring, right? So the client talks to the coordinator node, and then coordinator node coordinates
I
the
think same thing here also. It is not coordinator node. Actually, it is like whoever is a close by, he receives that request and he forward that request to the where the hash or where the key resides. I think in Dynamo, I mean that is a typical consistent hashing model, right? I mean that's my understanding.
correct. Yeah.
I think
So
here also, I think somewhere maybe they are not listed,
mhm.
but here also it should work that way because the client will send it to the request, any server will receive it, but that server will forward that request where exactly it resides, that the value or that hash, the key
Okay, makes sense. Okay,
should be maybe.
okay. Let's
Yeah,
verify.
we'll see that. Yeah.
Yeah.
So so actually, the whole point, right? I mean, it is not the thing, right? I was trying to understand. I mean, when I say Dynamo, what is when should I say Dynamo DB? I'm using it. When should I say Cassandra? I'm using it because we have clarity on MongoDB versus Cassandra or Dynamo, not the Dynamo versus Cassandra, right? So we should. That is the reason why I'm trying to understand. Okay, that's it. Nothing
I
else.
think I think they clearly mention, like to me, like when I read this, I feel that this could be the main point that the Dynamo could be used. I think they said multi-table relational database system is like what they are trying to discuss as part of this Dynamo architecture. So there are relations in between tables, which is missing in Cassandra. Like Cassandra is one giant table, right? Like what we saw was a key space. Here they are they are actually talking about tables and the relational database. So to me, I think the key difference between Cassandra and DynamoDB is the primary key, secondary key kind of configuration, which allows us to have some sort of a relation. Um,
Yeah, Alex,
I don't think so because
Yeah,
yeah.
it says that they wanted a very fast, very reliable system, and they do not need joins, apparently group buys or um, joins and group buys they did not need. So they say that would be RDBMS would be overkill and will limit scalability and availability. So that's why they did the Dynamo because they didn't want to use Postgres MySQL because use case is not the same.
okay. So that is in context of the Amazon services. Yeah. Is that the case you mentioned?
Yeah, they say they only need key access. That's it. You have primary key access. That's all. I give you key, you give me value. That's all you need.
Oh, okay, okay. Yeah, I now I understood it. Okay, okay, okay. Yeah, my bad. Yeah, yeah.
yeah, but we didn't conclude like when to use DynamoDB. Just
So the my point, right? DynamoD is a purely AWS infrastructure. Okay, one point is that it's purely on the AWS, right? I don't know whether other cloud we can use it directly without using that. Okay, but rest, right? Other than our I mean query language is different though, but other than like wide column, right? Um, the I think the Dynamo accepts the value of different types. I think every key and value, the value is not, the schema is not value. You can be string or you can be JSON or anything. I think the value for each row, right?
yeah, that's correct. And this is a managed service, right? This is
Yeah.
like, and it's basically it can limitlessly scale, right? So it provides like low latency, um, sort of experience and very high scaling, mm, real time data, especially for the real time data system as well, I guess. So, but isn't that the
But actually underneath both are consistent hash, I mean hashing model. But the similar logic, right? Both are using LSM tree underneath.
Yeah. Then why can't we use a Cassandra as well for that very same reason? I think it's because read
Cassandra
will
is
not be
complicated,
helpful.
right? Maybe, right? Complex,
Yeah,
more complex, right? That is.
yeah, more complex, and read will also require some query. Read will not be fast in Cassandra for sure compared to
Yeah.
DynamoDB. Yeah.
I think in Dynamo, I think we can maintain secondary indexes and all. I think Cassandra, I don't think so that is possible. Maybe partition, but anyhow, we'll read it, okay? And that just, yeah.
Yeah, this is good point, Srini. I think be um we should observe this one, the secondary index one. Like,
Yeah, we have to, because
yeah,
Cassandra, right? Short key is there, and what is the
correct.
cluster key is there, short key is there, right? Only two keys there, right? How you
Yeah,
how you partition your data, right? Or once or anything else is there.
no, these are the only thing. There is no other form of
Right
indexing.
here what we have here, primary key maybe, right?
Yeah,
And
so
secondary,
Dynamo
I don't
is
know.
primary and secondary. Yeah,
Okay.
cool. Yeah, shall we proceed?
So by default, Dynamo is a eventual consistent database. Therefore, any application where strong consistency is not a concern can utilize Dynamo. Though Dynamo can support strong consistency, it comes with the performance impact. Hence, if strong consistency is a requirement for an application, the Dynamo might not be a good option. And Dynamo is used Amazon managed services that very high reliability requirement and need tight control over the trade-off between availability, consistent, and cost effectiveness and performance. Amazon's platform has a very diverse set of applications with different storage requirements. Many applications choose Dynamo because of its flexibility for selecting the appropriate trade-off to achieve high availability and guaranteed performance in most cost-effective manner. Okay, so this is one of the reason, right? Because of its flexibility for selecting the appropriate trade-off to achieve high availability and guaranteed performance in most cost-effective manner.
Correct. Correct. Good point.
So many services on Amazon's platform require, yeah, so this is important. Right? The many services on Amazon platform requires only primary key access to a data store. For such services, a common pattern of using a relational database would lead to inefficiencies and limited scalability and availability. Dynamo provides a simple primary key only interface to meet the requirement of these applications. Any, that line means that we have foreign key. That's what they're talking about. And okay, wait a
Here,
minute.
to me, yeah, in my opinion, they are more like referring to the the strategies we have, right? Like, relational database primarily have master slave and all sorts of architecture, right? That actually creates the bottleneck in terms of scalability, right, or availability. Whereas here we are deviating from the master slave more towards serverless, like to improve the availability and scalability is how I would understand this.
Okay, but he's a SQL is high available, right? Right. MySQL is high. No, it's not high available. Strong consistent. Okay, fine.
It's yeah,
Yeah, fine, fine. System APIs. Any questions? The Dynamo uses put and get operations to write and read corresponding to the specified key. The key uniquely identifies an object. Key get the get operation finds a node where the object associated with the given key is located and returns either a single object or list of objects which with conflicting versions along with the context. The context contains encoded metadata about the object that is meaningless to the caller and includes information such as a version of the object. Okay. The put operation finds the node where the object associated with a given key. It should be stored and write a given object to the disk. It should be stored and write the given object to the disk. The context is a value that is returned with a get operation that is sent back to the sent back with the put operation. The context is always stored along with the object and used like a cookie to verify validity of the object supplied to the put request. Okay. Dynamo treats both object and key as an arbitrary array of bytes, typically 1 MB. It applies MD5 hash algorithm on the key to generate a 128 identifier, which is used to determine the storage nodes that are responsible for storing the key. Yeah, this is the standard.
Yeah, I'm just thinking, right? So, for example, I have added some item in my cart, correct? I never check out. So, what it will do is they will create some key for me and put the whole cart content on one JSON format in the DynamoDB, right? When I come back next time, it will just read back from this same place. So, that's one use case that they can achieve, right? And another thing is like they do MD5 here. So MD5 is like to identify the node where that key is stored. They do that MD5, and once they reach to the node, how do they identify my specific record, my specific key? Does anybody know that?
That means the key, your specific key, right? Key is a part combination of your user ID or unique identifier that are associated with the user ID, right?
Yeah. So maybe what you're saying is user ID is also passed with that request. So once they identify the node, then they can use user ID to locate my record. Correct? Something like that.
Yeah, I think yeah, with the DynamoDB, sorry, the get operation, we see that the key is being passed, right? So I think that's a primary functional requirement. Like we have to pass the specified key.
But they are saying that they would um, use that key to identify the node. Correct? That's what they are saying below.
Yeah, I think the key is a combination of unique identifier plus something else also. I think so. Maybe we'll see that in the down the architecture diagram. But that's a good.
Yeah, maybe it has that.
Are you
Uh,
trying to say that basically one is to achieve the basically the index of the object, and another is to achieve uh, the partition key? So you mean like combining the index of the object plus the partition key, like in
No,
like.
no, no. He's not saying talking about partition key. He's talking about Sagar or Srinivas, right?
Uh-huh.
Okay. How can I added to one item to same item to my cart and you added same item to your cart. Okay.
Uh-huh.
Now how is it differentiating whether you added and I added it? Because everything goes to the same node. Okay. Same server.
Hmm. So
Right.
it has to
So
be.
maybe
no,
either key should be part of the username or maybe the context should be part of that.
Makes sense.
I mean, Ruchir, that is my understanding correct?
I was saying that so key would give me the node identifier, right?
Yeah.
So so basically this is a cluster of DynamoDB, correct? And there are several nodes. So by using the key, I would only know on which node on the cluster that record could potentially be located. But after reaching to that node, how do they identify our specific record? There could be millions of record on that node also, right?
Correct, correct. Yeah, that is what. Yeah.
So
Yeah.
uh, I think isn't in consistent hashing, we have like key ranges being allocated to a particular node, like let's say if we just get an identifier for any unique record, there will be virtual nodes, and
Yeah.
then on virtual nodes there will be partitions created, right? And then the partition range would just tell us which node it is part of. um, isn't that the case here? Like to identify the node, we don't actually need to have a separate key. We just need to know like this key is part of which range, so whichever range it is part of, there will be a host map to that, and then that's how it will just go to that particular node.
That's correct understanding. That is how I am also envisioning. But I'm saying that once you reach to that node, there are millions of records sitting on that node. So how do you identify your own specific record?
So each node, as we say, like let's say if the whole index, is there, like if the whole index is constitute is created using the unique identifiers, then even the same node will have like the index with all the unique identifiers, right? So it will be just a search operation that could run across that node just to find that one particular record or object where it is located. Like
But
after once we figure out which node it is, then I think it will be a search. Um,
yeah,
But
but
where is that? Where, what do you search there?
yeah,
That's what his question is.
the
How do you know? How do you know? How do I know I have to set something, right? Where am I passing that information? That's what his question, I guess.
I think everywhere they are saying this specified key, right? So they say if they are saying that the key is the key uniquely identifies an object, that means like once the key is passed, using that key, we will figure out which partition range. Going to that partition range, that node, we will just should be able to have the record store on that, right?
But the if that understanding is right, that means key is a combination of something. That one combination is a unique ID is corresponding to your username,
yeah, that
right?
is how we can assume, but they are
How?
not stable
But
in that.
that's not how we do it in MySQL, right? In any relational database, we just have a uniquely identifiable primary key, right, or a composite key. So when we just have a record indexed using that key, right, which is uniquely identifiable in a particular table. So talking in only in perspective of table.
Yeah, okay.
So that's how I think. So I'm just thinking in similar terms, right? Like that primary key should be part of the table here, like whatever dynamo table we will create. Either you assign an additional UUID or a index unique identifier, which will be part of the index, or we have to make that primary key as as part of one of the fields in our record or object. Like let's say like storing it something like if you see here, the object is being stored like key, context, and object. If this is if this is how the record looks like, then key is actually part of the object itself, right? So
Yeah, yeah. I think they are using same key to identify node as well as to identify the record.
Yeah, yeah. Even that's what my understanding. Key is maybe we'll down the road we'll see it,
yeah,
but that's what my understanding. It's like kind of a uh, hash encoding decoding, right? Maybe like first
correct.
few bytes is a node and second few bytes is kind of a unique ID or whatever. Maybe.
Yeah,
No, so Srini, what I mean to say was, can I bring up the whiteboard here?
Yeah.
Okay, so what I mean to say is, let's say we have one record as ABC. Uh, okay, let's say we have one record as ABC. Like there are these three fields. Another record is A, D, E. And let's say if A is the primary key, okay, here. Uh, uh, and then let's say if we have third record being something like B, D, E, something like this, or maybe let's say B, E, F, something like this, and then something like C, F, G. So let's say if we are whatever range we have, the A range is could be tied up to, let's say, node one. Maybe some consistent hash.
What is A here? That's what I'm saying. What is A?
A is the primary key. A is the specified key I'm talking about. So whatever our operation, the way our operation will come is get A. Let's say if this comes in,
Hmm.
then oh my bad. I think it has to be AB. It has to be a uniquely identifiable record. So let's say if our operation comes in as an AB,
Hmm.
then with AB we just have one record. So let's say AB is part of A range. A range is mapped to, let's say, node 1. Okay, so in node 1 we can go to node 1, and node 1 just have two records. One is AB and one is AD, right? Then let's say if another operation comes in, then it will have, let's say, get BE. So with B being part of the second partition range, it will just simply go to node 2. And with node 2 we just have one record, like, which is basically that whatever record we have is BEF. So so that way, basically, if the primary key is part of the record, then it will be unique, right? Does
But
that
primary key
make sense?
is a primary key for a table. It is right, not for every entry, right? Or every entry.
It is every
Every
entry.
Every object has a
for every
key,
Every
right?
object.
object has a key.
Object has a key,
Yeah.
and then you ask for object, you get the payload, the value.
Okay. I think yeah.
Yeah, so I mean to say, like, the way, if let's say, if we do get AB, then there could be one record, and if we do, let's say, get AD, that it would be a different record, right?
So you understand, get AB, hash of AB gives the my node address where the AB stores it, and then it redirects to the corresponding row, corresponding node, and in that we have a row called row index. I mean primary key has a AB. We go
Yeah,
and fetch it. That's what he's saying, right?
exactly. Yeah, yeah. And if let's say if AD comes in, then it will go to the same node, because through our like a node calculation, or the hash calculation algorithm, it will go to the same node, but now it will look for AD in that node. So AD will again be uniquely identifiable record, which is ADE.
Okay. I think in Ruchir's use case, right?
Uh-huh.
Okay. So he logged in into Amazon account, and he is buying something like a mobile phone, right? He added that mobile phone to the cart.
Uh-huh.
Okay. So so, so now what is the key here? Is a mobile phone is the key?
No, there has to be, it has to be tied up with the username or
Yeah, that is what we're talking. Yeah.
Item,
So the key should be
no, no. It might be the item ID, right? Like you are just not at like checked out. Why you want to username there?
no, item ID will have multiple users who would have added that same item.
Yeah, yeah, but like one person, he's if he's logged in, it attached with the login ID and item ID. If not, that's the case. Like it is only item ID, right?
I can come after a month and refresh my page, right? If it's able to see the checkout page, a cart has been added, right? It will show, right? Usually, that
No,
means like you
not
are
not
issuing.
month. There might be the time period for it. I
No, but
that's what.
still, like let's take example 10 days time period is still there. It is showing, and that means we're issuing a get call and fetching it. Okay, that's what I'm
Okay.
saying. That means there should be some way of recognizing user with the item, right? That's what.
The cart will be okay. You mean to say that you the whatever cart is there that is attached to the user is what you're trying to say, right?
Has to be right. Yeah,
There has to be one-to-one correlation between the user and the card,
yeah.
because if you have the item ID, then it could be one to many, right? Because the same item could be part of many cards.
Yeah, yeah, that's true. But like if you log in as a guest, I don't know about Amazon part as a guest. Sometimes if you log in as a guest and if you add the cart, still it is exists. That time it might store something else with that, right?
I mean, if you log in as a, there will be some cookie or something,
Yeah.
right? Something local, right? That
I
might have been.
agree. I
Yeah.
agree. That point here also it happens, right? There might be some like yeah, there might be possibility user with connected, but like if you log in, sometimes we log in as a guest and we add to the cart, still it exists.
That means something we append, right? Prefix with something, right? That how we are going to do that. That's what we are discussing. It
Makes sense.
may not be the only the value, only the item. It
Yeah,
has to be
it
something
may be
else.
append with the something like, yeah, I
Yeah,
agree with you.
that is what we are talking actually. Yeah, it has to be some way of uniquely identifying who is originated, or what is the system that is originated. That is what we're talking.
And I think generally, like, if I think I have seen this in Amazon low level design, or the database design, I think they generally identify a cart, always identify the cart with a cart ID. Okay, so when they store the relations or the mapping, they generally try to store it with like user ID and cart ID, or maybe some cookie ID or unique ID with cart ID. They never actually associate a item ID, because the item ID could be duplicated, right? Same cart, same item could be there in 10 cards. Just one, let's say iPhone 16. iPhone 16 will be there, could be there in hundreds of cards, right? So, but you have to create a unique cart ID corresponding to every single card, and then that unique cart ID could be associated with the, could be added to the user ID, or maybe like some cookie or some other way.
But cart might have any other items also, right?
Yeah, so if once you create a cart table, or cart entity, that then there will be a unique ID for the cart ID, and then it will have items like that. Items, you can have any number of items.
Yeah, maybe like they are going with a composite key probably.
Let's take this offline, and everybody can share their understanding, because it's based on this only we'll have more understanding how the underneath the design is works.
But the paper didn't say anything about composite key or anything. You have a key and you get a value, and it doesn't care. It says it's a byte. It has no understanding. Is it a username or is it a shopping cart number or anything? It just say you give me key, I give you value, and know nothing about it.
Yeah.
Correct. Yeah.
Okay, Sagar. Then very good. So not sure whether we already have 7:15. What I was as part of 7 to 7:30, right? What I was thinking to discuss is two things actually. One is more on the API side, right? That means we covered a little bit high level overview how the API looks like, but maybe a little bit in depth understanding how to design the APIs and the other factors that are involved. So that's what actually I wanted to cover, but we don't have time. Maybe tomorrow we'll discuss about that.
Sure.
But anybody has any good reference material, um, like about API design? Um, it should include all headers, caching, security, SSL part, all these things. Yeah, it should be really helpful. I'm not able to find a good doc.
Have you covered the Alexu article, Srini?
Do you have one?
I think Alexu have. Yeah, let me share that.
I hope this will be useful for everyone. I mean, that's what.
Absolutely, 100%.
Okay. I mean, especially 7 to 7:30, it's more on the interview specific, so it has to be useful to everyone, not to one or two people. That's what. Okay. Yeah. Because nowadays we are covering heavy on the backend systems, right? Little bit on the application server side. If we have that knowledge, it is easier for us to connect all the dots. That's what.
I think it needs login. I shared the link. So this is the link I was talking about.
Yeah. I'm able to log. I'm able to see. Okay. Yeah, I think this is good. Huh? Okay.
Yeah, so I think it's also about the API safety.
Where is this? Get started. Oh, I have to sign in, huh?
Yeah, it needs signing in. Yeah.
Abba, my account is
Tarek,
locked.
DynamoDB is based on this Dynamo architecture only?
Dynamo, my understanding that Dynamo is a storage system. Dynamo DB built on top of that.
Yeah, yeah, that's, oh yeah. Okay, I was asking same thing. So if we understand this Dynamo architecture, then it should be easier, right, for understanding the DynamoDB, right? Is that correct?
It should be because, but maybe like we need a little bit of wrapper layer, how these requests are transactions are maintained and all, right, in the DynamoDB side. I
I
don't think
see,
so
I
they're
see.
talking about here. They're talking heavily on how the data has been stored under the storage system and its replication across different regions and nodes. They're talking about it.
Okay.
Yeah, but actually, even I wanted to understand a bit more about DynamoDB too.
Actually, Srini, we did cover DynamoDB if you remember in the other PST group.
Yeah, the with the Jagan, right?
Yeah, yeah, yeah.
Yeah,
So
yeah,
time we were talking about that is based on this. So this we didn't cover. Actually, I think now we are covering actual the root of that. In that, I think we're talking about the more on the replication and all those internals, if you remember.
yeah, yeah. That's a paper, right? Paper reading.
Right, right, yeah.
Yeah.
Sagar, are you able to log in?
Yeah. So actually, that article, I'm still not able to see it completely. I doubt that it needs a subscription or something. But on the other side, I found this other article